Welcome to another week of the Remote Sensing Lab. I wanted to start by thanking you for all of the work that you're putting in to this lab. I've been looking over the assignments the last several weeks, and they're coming in looking really good. And I've been hearing that it's also been a lot of work for a lot of you. So I just really want to thank you for all the work you're putting in. I know this transition can be challenging. Depending on a lot of different factors. And so just really appreciate that. And the hard work that you're putting in is really coming through. So really grateful for you guys. I also want to say that this experience I think is really valuable. I think that this is one of those things that you can take away and talk about at a job interview. And so, as you're putting in a lot of hours and, it's been a challenge to get the remote desktop and all that stuff set up. Just know that these skills will be really valuable to you in the future. And they'll allow you to work from home at future jobs and things like that, which is nice. You can have a nice morning and have another cup of coffee. And so, just keep that in mind. Each week I'm trying to refine these videos more and more and really to refine how I'm able to help each of you. So I really appreciate the feedback. Keep giving me feedback. I'm going to keep trying to improve these videos, improve the communications I have over email, things like that. And with that, this week we're jumping into supervised classification, which is a companion in a lot of ways to unsupervised classification. It's really just a different approach. And so where last week we kind of just fed the image to an algorithm and it classified the image using no information at all, in this lab, we're giving the algorithm both the image and some training data. So we're saying this area is forest and this area is pasture and crop and this area is developed. And then using that to use these different classifiers to classify the image into these classes that we're interested in. Wow, that was classes a lot of times. So as you're getting a sense of, classification is very important in remote sensing. It's one of the absolute valuable things. So really, I just, encourage you to try to get a lot out of these two labs in particular, because they're ones that at least having this understanding will be useful to you. And then if you're able to, run with remote sensing, and it can really be a valuable skill. So with that, on to Lab 8. So this first step is going to be really simple. You're just going to be clipping your image to our watershed boundaries. So the only thing that I wanted to point out is it doesn't describe how to how to find the image classification toolbar. So to get that, you're just going to want to go to this Customize menu up at the top, and then go to Toolbars. And then you're just going to look for, there it is, Image Classification, and then it'll pop up, and you'll be right where you need to be. So. So for the next step, we're actually going to be defining our different classes and giving the algorithm the data for each of the classes. So I've already done this for water. I did that, before this video, but I thought I'd just show you how to do it for forest, and it's going to be the same for each of the classes. So I'm not going to show you in detail like every step, or describe it in detail, because I think the lab does a lot of that. But I did just want to show you how to do it so you can orient to it. So once you have the image classification toolbar open, you're going to open the training sample manager here. And you can see I've already done this for water. And you're going to use this draw polygon button. So you'll just click on that. And I'm in a spot where I already have an area of forest that I want to digitize. And so I'm just going to draw it. And you'll notice that I'm kind of avoiding those areas where water comes in, because you really want your training data to be a pure class. And so I'm going to try to make it pretty big and give the algorithm a lot of pixels to work with. But I'm trying to make it pretty pure. And then once I'm done, I'm just going to double click and it's going to add it here. So I'm doing this for five training areas for 5 training polygons for each class. And yeah, I'll show you once you have those 5 polygons what to do next in just a sec. Now I've finished getting my 5 polygons for forest, but one thing that I wanted to show you real quick, you can see that it's kind of blurry. This is Landsat imagery, so the resolution is pretty coarse. And so if you're trying to get a better idea of what's going on in the image, like is this forest or is it unforested, I would recommend turning on the imagery base map. And so now when I turn this off, I can look underneath and I can see that that this is all forest under here. And so I've classified it that way. The one thing you just want to keep in mind with that is that the base map is a lot newer imagery than the one we're working with. I think the one we're working with is from like 2006. And so this base map is probably 2018, 2019, something like that. So just keep that in mind, but otherwise that's useful. And so now I have my 5 classes or my 5 polygons. So I'm going to select those 5. And then I want to click this merge training samples, and you can see it just changed the color, and they'll all be all those 5 will now be homogeneous. And I'm just going to call this forest. And after this, I'll do the same for my other 3 classes, and we'll pick it up at that point. And I just finished classifying my samples. So I ended up doing a little bit more than 5 for each class. For like crop and wetland, the polygons were a little bit smaller, so I ended up doing a few more for those. But I ended up with something that looks like this. I tried to just have a distribution for each class, kind of spread throughout the image, some variety for each class. And yeah, so once you're done, then you just create a signature file. And you can see I already did that. I named mine signatures. And yeah, that's it for step 2. And we're moving on to step 3. For step 3, we're going to take a closer look at the spectral relationships between each of the classes we just defined. So within ArcGIS, there are a couple different ways that we can do that. So we're going to be looking at histograms of each of the bands that show each of our classes. We're going to look at scatter plots, which are also going to show each of the bands, and all of the classes will be color-coded. And then we can look at the statistics of each of the bands for each of the classes. And so you're going to, once you've had a chance to look at this, which I'll show you in just a second, there are just going to be 3 questions that you're going to want to answer, and that's going to be it for step 3. But these questions are getting at some of those relationships between the classes that we just defined. So you can see that I have my scatter plots, and oh, dang it. Obviously, I just pressed a button you shouldn't press, but it was easy to get the scatter plots back. So I have the histograms over here. So that's showing for each of the bands the values for each class. So I went ahead and color coded mine because it suggested to do that. And so you can see like the water band, this blue band, is really distinct, having really low values, really densely clustered in those low values for each of the bands. You can see that the urban is pretty reflective across all the bands. And you can see that vegetation down here is very reflective in the near infrared. So crops and forests especially. So kind of what we would expect, and you can scroll through these and explore more. So hopefully you'll find lots of things to talk about in each of these. For the scatter plots. It's just a different way of looking at these. And the idea here is that it's looking at the relationship between the blue band and these other bands. So hopefully, if these are distinct bands, distinct classes, they're you know showing up as distinct in these scatter plots. And in this case, they are distinguishing a fair bit. There's quite a bit of overlap here in the green, here comparing the blue and the green. But here where we're plotting the near infrared against the blue, you can see that the classes are fairly distinct. And so I'm hoping that once we get to classifying this using the algorithm, that it'll do fairly well. So with that is the end of step 3, and we'll move on to step 4. All right, so we're over halfway through, or about halfway through this lab at this point, and we're at the point where we're actually going to be running the classification. And so a lot of this now will look familiar compared to last week's lab, because we're kind of going through a lot of the same steps of running the classification and post-processing that we did last week for unsupervised classification. It's just this week we're giving the algorithm this training data. So you're going to be led through some steps on how to perform the classification. And then especially once you get to this section, you're going to be conducting post-processing tasks. So you will be asked a question in here as well. But you might remember that we ran that majority filter tool twice last week. And we'll do the same thing here again. You can see run it and run it again. And then we're going to be running this boundary clean tool again as well. And that's just trying to clean up any just individual pixels that might be erroneous. And so it's better kind of clustering our classes. And then we're going to do, again, similar to last week. You may have noticed by the time you get through these steps that we lost our class names. So we're going to create a new column in the attribute table to add our names of forest and developed and wetland and etc. And so you'll be given steps for that. And then you will give each of the classes an appropriate color and export a layer file, which will save that symbology. And then again, just continuing with what we did last week, we're going to use that extract by mask tool to separate out each of the individual watersheds so that we can compare the classes within each watershed and do more of a quantitative analysis of the different proportions of each class in each of the watersheds. So this last part is just determining the percentages of land cover. And that's pretty much it. So kind of a long step. And I thought there was something else I was going to say here, but maybe not. So I'll just show you, I'm again not going to show you the steps, because I think if you did last week's lab and got through it, you'll be fine here again. But you can see the outcomes here that I have each of these individual classes for each watershed. And they're symbolized with some colors that intuitively make sense for me. You can use whatever class colors you like. And if you look at my attribute table down here, which my head might be in the way of, so I'll bring that up. Okay, there we go. Still might be a little small, but hopefully you can see it. You can see that I have this percent column with each of the percentages, right? So we're going to be doing a few different, so hopefully once you get to this percentage step, that'll be fine. Oops, sorry, wrong place. But we're going to be doing kind of comparing our unsupervised classification to two different methods of supervised classification. So we're actually going to want a table to put the data into. And so over on Canvas, there's this table of percentages. And so you can get this. The way I did this was just selected all of this and just did Command C. And then if I go into Excel, I can just press Control V, and it's going to paste it right in there. And then now you have a place where you can, I actually don't know how to do that in there. I thought I was going to make this look really cool, but I don't know if I can. So anyways, now I have a place where I can, for each of these watersheds, put these percentages into. So you'll want to get the percentages from last week for each of the watersheds and put them in this unsupervised. And then for this week, we're going to have two different classifications. The first is this interactive one that we just are doing right now. And the second will be a maximum likelihood classification. And so you'll fill in each of these with those. And that's kind of where we're going from here for the rest of the lab. So hopefully that's fairly clear. And yeah, we'll move on to step 5. For step 5, we're going to go through a lot of the same steps that we went through in step 4, but with a different type of classification called maximum likelihood. So this is just another algorithm that can be applied to the training data that we give it. So to start off, you're going to perform the classification, and it'll give you steps for that. And then you're going to run through the post-processing steps that I just talked about in the last one. And, by now you're probably getting pretty good at just going through those steps. And then adding the field names or the class type names in a new field in the attribute table, calculating the percentages for each of the watersheds. So you're going to extract by mask each of the watersheds and then calculate the percentages, the same steps as before. And so once you're done with all of that, getting all of the percentages and everything, you'll have a map. You can see I have, this is my maximum likelihood map. And you can see I have it for each of the watersheds here. You can also see that I have the interactive map underneath from our previous classification. And you can see it's a little bit different. The maximum likelihood classified a lot more wetlands. And so I think that's an error that I'll talk about in a minute. But yeah, so that's what we ended up with. And then I forgot to mention this in the last step, but you'll be making a map for each of these. So you'll see on Canvas where you'll need to upload a map for each of the maximum likelihood and the interactive supervised classification. And then the other thing you're going to be finishing with this step that we're going to be working with more in the next step is our table here. So you can see I've filled this in. I had to go back to last week's lab to fill in the unsupervised values. You may already have that. And then you can see it, just that I went through for the 2 supervised classifications this week and filled those in. So yeah, like I mentioned, the wetlands really only the maximum likelihood supervised classification came out with there being so much wetland. And so you can see, especially in this Middle Potomac, there's a discrepancy here between the interactive classification and the unsupervised classification, but really, 25.8% of the Middle Potomac being wetland is I haven't spent a lot of time in that area, but that seems really high. So I would suspect that there's something, some issue with that. And my guess is that I had a really hard time distinguishing between wetland and forest. And so I think that's probably just a pretty big challenge that I think probably what happened, you can see that forest is a lot lower here. And so basically we had what you would call confused classes, where the algorithm, there wasn't a lot of distinction between the forested class and the wetland class. And so some of the forested pixels, or in this case, maybe a lot of the forested pixels, the algorithm was saying, well, that's probably wetland, when in fact it probably is not wetland, it's probably forest. So it's just, maybe you had the same difficulty just distinguishing between forested and wetland pixels. And I think that's a big challenge. And there's only really so much we can do, looking at satellite imagery with that. Maybe if we had higher resolution satellite imagery, we would do better. So anyways, that is step 5. And let me bring it back up. And then in step 6, we're going to be working with the table to create some comparisons between the different classifications, and then you're going to be answering a bunch of questions. So I will show that in a minute. So the last step is really very simple. I thought it was somewhat more detailed, but you're actually just going to create this chart, and then you're going to have some questions that you're going to answer. So it's basically just kind of asking you to compare and contrast the results. And I'd like you to go into, give this some thought. It's worth thinking about what the different algorithms, how they're approaching this, and maybe why there might be some differences. I talked about the confusion in mine between forested and wetland classes. Yours may be similar, or it may be different. So it's going to be important for you, especially if you have big differences between classes, to talk about that in your responses. I'll show one other thing. So I ended up formatting my table in this way, and you can see I added like a prefix for each of the rivers here. And and you need to have all of these in all of your headings in a row. But if you have it formatted like this, and you don't have to do this, but you can create a chart, which can be a good way to look at your data. So I'll delete this just so I can show you how I did it. But if you have it formatted like this, you can just select all of your data, and then you want to go to, did I lose where it was? Here it is. It'll just be, if you just click recommended charts with this data selected. I really liked this one. And it can just give you a different way of looking at, looking at just the numbers kind of makes my eyes bleed. And so here you can, get a more kind of comparative look at these. So you can see, for the most part, these line up pretty well. There's this big difference between these two, and sure enough, that's the one that I talked about earlier, where a lot of the probably forested pixels got classified as wetland. So it just can be a helpful way to look at the differences. And if you have it set up this way, there are a whole number of ways you can look at your data. So again, you don't have to do that, but I think it can be helpful for kind of exploring and understanding what's going on. And then you can, use what you've learned about remote sensing to think about why there might be some of these differences. So that's pretty much what I have to say for Lab 8. I hope it goes pretty smoothly for you, and yeah, of course, feel free to submit comments or questions to the discussion board. I forgot to publish that last week, so I will be sure and publish it this week so you can use that. And yeah, I wish you the best of luck. All right. Finally, don't forget to practice good data management. Make sure you know where your data is. And if you need a refresher, be sure and watch the YouTube video on data management for NR323.